let's talk about properties of equality here. You already know them. It's just that you may not have been given a name to them. So first of all, what we start off with the addition property of equality is if A equals B, then what happens is if we add some value to A, to keep the equation equal, we also have to add the same value to B. And that's really how the addition property, the subtraction problem, we start. If A equals B, then subtraction property, remember this time is if we subtract something from A, then we need to subtract the same value from C. Multiplication property, we start with A equals B. Then if we multiply A times C, then we must also multiply B times that same value of C. And then finally, if A equals B, but we're doing the division property of equality, what that says is if we divide A by C, then we must also divide B by C to keep the equation in value. I might be getting a little bit ahead of myself, but C, by the way, is not allowed to equal 0. We can't work with a fraction when there's a 0 on the bottom. And that's probably more of an Algebra 2 topic than geometry, but just as an aside there. The big idea here is when you divide one side by C, you have to divide the other side by C. Distributive property, we've already kind of looked at. Distributive property says that you take what's outside the parentheses and you multiply it by what's inside the parentheses. So I kind of put the rainbow looking figure in the wrong place. Let me put it right here. But what we end up with is A times B plus A times C. A couple of other properties, going back to if we start with A equals B, then what we can say is that A may be substituted or let's say replaced by B in any expression or equation. If they equal the same thing, then instead of writing A, we can write B, or vice versa. The reflexive property says that for any real number A equals A. What I, as a geometry teacher, like to say is that if you look in the mirror, what do you see? You see a reflection of yourself. That's just kind of a memory technique to help you remember reflexive property. But all that it's saying is a value will always equal itself. The symmetric property says that if A equals B, then B equals A. So we can have the A on the right side equal to B. We can have A on the left side equal to B. It doesn't matter where they are. It doesn't change that value. They're still equal to each other. And lastly, the transitive property says that if A equals B and B equals C, then what happens is that A equals C. And I like to do kind of a play on words, which is transitive property. Transitive kind of sounds like transport. So what happens is A equals B, B equals C. Because B is in both of these first two sections here, we can transport A across B, and that's where we end up with C. Now when we use the properties of equality down here, we can use them to justify steps in solving an equation. So that's what we're shooting to do. Bad choice of words. That's what we want to do when we, as we work towards an assessment later on in this unit. But two-column proof, just a real quick introduction to this, is a common format used to organize a proof. And the thing is what happens is we list the statements or steps in our process here, and then we want to justify each of those steps with a reason. And we use our reasons, like the properties of equality above, to help us when we're, in this case, going to be solving equations. So, what can be used as reasons? The properties. So the big ones are going to be the addition property, the subtraction property, the multiplication property, and the division property. And let's see how they work. So here's our equation. 4x minus 1 equals 27. That's the problem. That's what's given to us. So we write given for our reason. Well, our next step in here says 4x equals 28. Well, where did we get that value? If you go back up to the problem, what happens is we added 1 to both sides. And notice, 27 plus 1 is 28. So what we can say down here in the reason is we can write this statement because we used the addition property. And then our last step in this proof is we ended up with x equals 7. Well, how did we end up with x equals 7? What we did is we ended up dividing both sides of the equation by 4, and because we divided both sides of the equation by 4, we say that we used the division property.